Hello and welcome back. Today we'll be doing question 3 from the 2010 Step Paper 3. So, let's get started. Question 3. For any given positive integer n, a number a, which may be complex, is said to be a primitive nth root of unity if a to the n is equal to 1, and there is no integer m such that 0 less than m less than n, and a to the m equals 1. Write down the two primitive fourth roots of unity. Let Cn of x be the polynomial such that the roots of the equation Cn of x equals 0 are the primitive nth roots of unity, the coefficient of the highest power of x is 1, and the equation has no repeated roots. Show that C4 of x is equal to x squared plus 1. Part 1. Find C1 of x, C2 of x, C3 of x, C5 of x, and C6 of x, giving your answers as unfactorized polynomials. Part 2. Find the value of n for which Cn of x is equal to x to the 4 plus 1. Given that p is prime, find an expression for Cp of x, giving your answer as an unfactorized polynomial. Part 4. Prove that there are no positive integers q, r, and s such that cq of x is equivalent to cr of x, cs of x. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started. The primitive fourth roots of unity are e to the pi over 2i and e to the 3 pi over 2i. Notice that e to the pi I is not a primitive fourth root of unity because e to the pi I squared is equal to 1. Now we'll find C4 of x. C4 of x requires roots x minus e to the pi over 2i and x minus e to the 3 pi over 2i. Thus, C4 of x is equal to x minus I and x plus I, which should give x squared plus 1, as required. Now we'll move on to part 1. The primitive first roots of unity are just 1, and the primitive second roots of unity consist of just e to the I pi, which is equal to negative 1. The primitive third roots of unity are e to the 2 pi over 3 I and e to the 4 pi over 3 I. The primitive fifth roots of unity are e to the 2 pi n over 5 I, where n is equal to 1, 2, 3, and 4. The primitive sixth roots of unity are e to the 2 pi n over 6 I, where n is equal to 1, 3, and 5 only. Using the same method as above, we can see that C1 of x is equal to x minus 1, C2 of x is equal to x plus 1, C3 of x is equal to x squared plus x plus 1, C5 of x is equal to x to the 4 plus x cubed plus x squared plus x plus 1, and C6 of x is equal to x squared minus x plus 1. Now we can move on to part 2. Here we have x to the 4 is equal to negative 1, and therefore x to the 8 is equal to 1, so n is equal to 8. Now let's move on to part 3. We have x to the p is equal to 1, and therefore x to the p minus 1 is equal to 0. This can be factorized into x minus 1, x to the p minus 1, plus x to the p minus 2, plus all the way to plus 1, which is equal to 0. Since 1 is the only non-primitive pth root of unity, we have Cp of x is equal to the sum from r equals 1 to r equals p minus 1 of x to the r. Finally, let's move on to part 4. So we have CR of x and CS of x sharing no roots, and therefore if CQ of x is equivalent to CR of x, CS of x, then because CQ of x is equal to 0, then we have CR of x is equal to 0, or CS of x is equal to 0, so Q equals R, or Q equals S, as required. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.